So let's do some polynomial long division on a stranger looking division. So let's say I had x to the fourth minus 1 and I wanted to divide it by x plus 1 for some reason. Well, first of all, does this have any horizontal asymptotes? Well, the degree of the top is 4 and the degree of the bottom is 1. In this case, it does not have any horizontal asymptotes because we would need the degrees to be equal or the degree on top to be less than the degree on the bottom. What about oblique asymptotes? Well, that only happens when the degree of the top is 1 greater than the degree on the bottom. So again, nope. So this has no oblique, horizontal, or oblique asymptotes. But let's do the division anyway for practice. You set it up with x plus 1 divided into x to the fourth. And one thing that's slightly new is that you need to put some blank placeholders in here. So we're going to put the missing terms. You can pretend they're there without writing them there, but it gets really icky in terms of organization if you don't. So let's start. We have new leading over leading is x cubed. X cubed times 1x to the fourth plus x cubed. You now subtract, and you end up with negative x cubed. Drop down the 0x squared. And our new leading is negative x cubed divided by the static leading, which is negative x, so that's negative x squared. We now multiply again. We end up with negative x cubed minus x squared. We subtract. You got to be real careful with these negatives here. We end up with positive x squared. We drop down the 0x. We have x squared over x, which is x. And now we multiply again. X times x is x squared. X times 1 is x. We subtract, and we end up with negative x. Drop down the 1, and we keep on going. The degree here is 1, the degree here is 1. So we keep going. So we end up with negative x over x, which is negative 1. Negative 1, negative x. Negative 1, we subtract, and we end up with 2. So we now know that x plus 1 does not divide evenly into x to the fourth plus 1. Well, let's verify that this is actually the right answer. So we would do that by multiplying x plus 1 times x cubed minus x squared plus x minus 1 plus 2 over x plus 1. And if we multiply this out, we end up with x cubed times x plus 1 minus x squared times x plus 1 plus x times x plus 1 minus 1 times x plus 1 plus 2. X to the fourth plus x cubed minus x cubed minus x squared plus x squared plus x minus 1 plus 2. This is where I miss having you guys check my work. Let's see what cancels here. This is gone. This seems to be gone. This seems to be gone, leaving us with x to the fourth minus 1 plus 2, which is x to the fourth plus 1, which is indeed our dividend, which verifies our division is correct. A neat trick I want to show you is that when you're dividing by a term that looks like this, a binomial of x plus or minus a constant, there's a shorter way to do it. So let's say we had x to the fourth plus 1 and we're dividing it by x plus 1, which is what we just did. I'm going to do something else and see if it helps. I'm actually going to take negative 1 and run it synthetic division wise through the numerator here. The coefficients are 1, 0, 0, 0, 1, because that's x to the fourth, x cubed, x squared, x, and the constant. Let's see what happens here. Well, does it divide evenly? We know it doesn't, so it shouldn't come out to 0. 1, 1, 1. No, it's negative 1, negative 1, 1, 1, negative 1, negative 1, 1, 2. Remember, this is the remainder, constant x, x squared, x cubed. So what does that mean? It means that the factor, if we factor this out, it's what's left? 1x cubed minus 1x squared plus x minus 1 plus 2 over x plus 1. Does that look familiar? It should, because that's exactly what we had right here. So is there a link between synthetic division and polynomial long division? Absolutely. The link occurs when you are dividing by x plus or minus a constant. We will definitely talk about this more in class.